All right. So, Advent of Code 2015, day 2. Let's get started. Okay, so correct screen. Okay, so the elves are running row of wrapping paper. So we need to submit a new order. They have a list of dimensions for each present, length, width, and height. Okay, they need to order exactly what they need. Fortunately, every present is a box. Right rectangular prism. So we need to check now what's right rectangular prism exactly. We need to calculate the wrapping paper gift. Okay, we have to find the surface area of the box. So this is the equation. This is the first one, and the elves also need to a little extra paper for each present, the area of the smallest side. So we have to calculate the wrapping paper for each dimension or for each line. We need to check the surface area, and then we need to add the area of the smallest side as an extra slack. Okay, so let's see the rectangular prism in Wikipedia. So it is a normal gift or box type. It has like six faces or six surfaces. Each opposite face are equal, and then it's characterized by three characters like the length and the width and the height of the box. We can calculate the area with this equation or ABC or like length, width, and height. Okay, it's straightforward. Let's go to the code. Okay, so it's not working. Just a second. Yeah. So okay, so yesterday we did some refactoring to the main function. Now it accepts parameters like year and day, and then we need to add different like each solution we add in a different folder. So let's start by day 2, and then we need to create the files 02, and we need to create solution.go, and then we need to create the import.txt. You can create them any way you like. Let's go to solution. So the solution, it's empty. We need to create the package, and also we need for each solution solve function. It received input as string and doesn't output anything. So let's, for testing, let's do some print. Okay, from day 2, and then let's go back to the main function. Okay, so in main we need to import the module or the we need to import the day 2. So let's import the day 2, and then we need also to add it in the case here to the switch statement. So we have for the day 1, and this is then we have it now for day 2. The name is day 2. Okay, let's run it. So go run main go year 15 day 2. Okay, from day 2. So okay, so now we have the solution is running. Let's start implementing. The best way is to characterize a present or a box with the 3 parameters or 3 attributes, which is length, width, and height. So we can do it in Go using struct. So we have a type. The name of the type is present. Present, correct. And it's struct. And then the struct is has length, width, and height, and all from the type integer, all these attributes. We receive each line as let's go to the previous screen. So we have for each present we have it dimensions as string 2 by 3 by 4, and then we need to put it in the input file. So here's its input file. We need to convert it to somehow that we can deal with it. So we need to create a function called parse, for example, parse line to present, and then it has an input as a string, line from string, and it's supposed to give us the present. Okay, so since it's from this style, we have two approaches here. First one is to split the string by x, and then we get array or slice for 3 elements from string, and then we convert each element by itself to integer, and then we create the present object. Or we can use something else. We can use the scan or the scanf formatted scan that used for strings. Okay, so the output of it, so let's start first, create a p present. Okay, so the scan, it has two output, the number of successfully scanned items, and then error if any. It's in format packages, it's called scanf. So the difference between scan and scanf, just one read from the standard input, and the other one is reading from the string, the supplied string. So we need to parse the line. We need a string which is some digit multiplied by some digit, also multiplied by some digit. And this will give us reference, or it needs a reference to change directly in the memory. So we need the length, width, wrong, okay, dot height. Okay, so this send we can check the statement. So we do this combined if. So this is a initialized condition, then if not equal to, because we have like ABC or like links, width and height. Also, if have any error, we need to output like format print f. Okay, so error, parsing the line and the error itself. So we need to pass the line and the error itself, and we need to exit because exit. We need to exit. Okay, so if everything works perfectly, so we just return the present. Now, so this is for a single present, for a single line. But what we need to do, we need to get all the lines. So let's go to presents, for example. Let's have presents, and it's slice or array from present, and we need to parse it. So what we have the input. The input is multiple lines. So we go for we don't care about the index. We need the actual line, range, input. Or actually we don't need the range because we don't have it like input, but split. So we use the strings library and split the input by /n. And then we use the range for this. Okay, and that's it. So if the line is empty, we don't do anything. Continue to the next one. If the line is not empty, so we have an actual line. So we need to append present. Okay, so present, we need to calculate it. Presents equal a bit weird. Append the presents. We need to parse each line. So parse line to present and then parse the line. So what does this do? It gives us list of all the presents, and it's reading every line, parse it, and convert it to present. Let's just for a testing purpose. Okay, so let's continue. We'll test later. We need now to calculate the area. So let's have another function. Calculate serve. Let's see what they need exactly. Okay, so they need to calculate wrapping paper area, and we receive a present and we return number of the area. Okay, so it's two part. The first part is to calculate the surface area. The second part, the slack, or smallest area of the smallest side area of the smallest side. So we need to add function to this struct or this type in Go. So how we can do it? So we need to calculate the dimensions of the area. So function p from present, and what we need to do, we don't have the name is surface area, and then we return int. Okay, so it's straightforward from the equation. Return 2 multiplied by present links multiplied by present dot height plus 2, or we can do exactly as it's easier. Present length multiplied with present width plus present links multiplied by, it's just so much text to write, then width multiplied by height. Okay, so it's straightforward. Calculate. So we have area or total 0, then 4. We don't care about also the index present. We can do actually p range presents. What we will do if okay, so total plus equal p dot surface area. So for now, let's just check the surface area if it works. And what's the name? Calculate wrapping paper. Okay, so wrapping paper area presents. Let's say part 1 area. It's a decimal, so let's do wrapping paper area. Let's try to run it. Missing return statement solution 6. Okay. Sorry, forgot to return it. Return total. Let's try to run it again. We need to clean it up. So this one, remove it. No need. Error parsing. Okay, so no parsing, error parsing. So let's debug it together. It's a digit multiplied by a digit multiplied by a digit, length, width, and height. So I told you. So we are dealing with pointers, so we need to pass the reference for the pointer, and then now the area is 52. So we see. So the surface area is correct. Now we need to calculate the slack. So the slack need a little bit more need to find the smallest two sides. Okay, so we need to find the smallest two sides. So it's just tedious to do smallest two sides and return int and int. So Okay, so smallest two sides, it's just straightforward. So let's see, the minimum is the present dot length, or we can take another approach. So we can compare each one of them with 2. We can compare the lengths with the width and height. Then we can compare the width with the lengths and height, and then we can compare the other 3. If it's not, then both of them it's 2. So if the length is more or equal than width and length more or equal the height, so this means that the width and the height are the smallest 2 sides or 2 edges. So smallest 2 edges, actually, not side, 2 edges, smallest 2 edges. Okay, so then we return the width and the height. So the same we do it if we compare the width with the length and then the width with the height. If so, we return the length and height. So this is bigger than this one and this one, so this one both are smallest. Otherwise, the last option is the height is the longest, so we take the length and the width. Okay, so this is the smallest 2 edges. So how we use this one? So we need to use it with finding the slack area. Let's have another function, p present slack area. It's integer. It's the area of the smallest side. So the smallest side. So first we need to get A and B are the smallest side. P dot find basement. Oh, not this one. P dot smallest 2 edges. Okay, so now we have the smallest 2 edges. Then we just multiply them together. Multiplied by V. So now we have the slack area. So let's add it here. So here we have the area is surface area. Then we add the slack area. So here surface area total plus equal p dot slack area. So this is supposed to give us 58. So it's correct. Let's try it with another one. So it has 1 by 1 by 10. Let's try to the other one. It's 43. So it's correct. It's 43. And now let's get the full input. So this is my input. Let's have it in the input. And okay, let's run it. Okay, so we have this number. Go. Okay, so submit. Oh, it's correct. Nice. So this is the first part is done. So let's do the second part. So okay, the elves are running low of ribbon. Ribbon are all the same width. Okay. So only we need to worry about the length of the order, which they would like to be exact. Okay, so the same as the previous one. The ribbon required to wrap the present, the shortest side. Shortest distance, it will be the side, the smallest parameters. Okay, so the side with the smallest parameters, I think we can use the same of the small edges, the smallest edges. Okay. On the input type. Okay, so the present dimension. So it's 2. The smallest 2 edges is 2 and 3. So it's 2 plus 2 and 3 plus 3. And then we need. Okay, so the bow. So each present is wrapped with the paper. We need to wrap it from the smallest side. And also we need to add something similar to the slug, but it's the bow. So let's do it together. Let's remove this input to have 1 by 3 by 4. Okay, so run it again. It's supposed to be 58. Okay, so let's do something similar to this one. Not to write this one. Calculate length of auto-written. Okay, ribbon. Okay, total. So instead of surface area, what we need to get some function is similar. We need function present ribbon length integer. So first we need the similar to this one, we need the smallest sides. So b dot smallest two edges, and then it's just multiplying it by 2 and then summing them together. Okay, so it's straightforward. Return a plus b, 2a plus 2b, 2 plus a plus b. Okay, so I think this is correct, not sure. Okay, so this is the ribbon. So let's calculate the ribbon size. Okay, so this is, where's the solve function? This is the solve function. Okay, ribbon length, calculate the length of the ribbon, presents, and then format println. Okay, first we need to go one line here, and then we need to format f, and then part 2 length of ribbon. It's also digit, and okay, ribbon length. So it's correct 10. Now we need to calculate the bow. So we can also add another function to see it. Function be present ribbon bow, and then it's also integer. So we return it's multiplied in 3 multiplied by each. Okay, so 1 by 3. Okay, so return p length multiplied by width multiplied by height. Okay, so let's check if it's correct. It's easy, looks easy. Okay, bow, ribbon bow. So I remove this and this, remove this. Maybe actually we can just add it here. Okay, let's try to run it. Okay, so it's 34. So let's see how it is in this one. It's a 14. Okay, so it's wrong. 1 by 1 by 1. No, it's correct. So it's 34. So it's correct. I was checking this one. So now it's correct. Let's get the full input. So here's the full input. What we said. Okay. So let's check the output. It's 31. Let's copy it. And then let's check together. Nice. So now day 2 is done. It's easy. We learned how to make struct in Go. We learned a couple cool stuff. We learned the string scanf, and yeah, it's nice. Nice practice. See you tomorrow in day 3.